Follow-up studies of candidates' planetary systems found by NASA's Kepler mission suggest that companion stars make some worlds appear smaller than they really are. The Robo-Owl system at work on Kitt Peak. Christoph Baranek, NASA's Kepler mission, gave astronomers a bountiful supply of homework. Checking up on the 4,000-plus candidate exoplanets that it turned up is a daunting task. Among those tackling the list is the Robo-Owl team. Robo-Owl is an automated laser-guided adaptive optics system, which when hooked up to a large telescope, most recently, the 2.1 meter on Kitt Peak, enables rapid-fire observations of a couple hundred stars each night. The Robo-Owl team has been checking each of Kepler's candidate planet-hosting stars to see if any other stars are lurking nearby. Nearby stars can muck up estimates of what the host star is really like, temperature, size, and even create signals that look like exoplanets but aren't. It turns out that extrastellar companions can also make exoplanets look smaller than they really are. Carl Ziegler, University of North Carolina, Chapel Hill, reported that takeaway as part of the big picture results from the Robo-Owl project on January 9 at the American Astronomical Society meeting in Washington, D.C. Of 3,857 stars observed with Robo-Owl, more than 600 had stellar companions. The light from this extra star can contaminate exoplanet detections with extra light, making their dips appear smaller and thus giving the impression that the planet candidates themselves are smaller than they really are. Broadly speaking, having another star in the system means planetary radii are roughly a factor of 2 larger than they appear. The team found that due to this contamination, 8 of the 26 potentially rocky, habitable zone worlds studied might be gaseous. Among the candidates are the confirmed planets Kepler 438b and Kepler 437b. If these worlds orbit the primary star in the system, they're still rocky, but if they instead orbit the secondary star, they're 2 to 3 times larger than estimated and thus gaseous. The team also sees indications that hot Jupiters are roughly 4 times more common in systems with more than one star than they are around single stars. Astronomers have previously suspected that a stellar companion could gravitationally mess with a gas giant enough to push it into a much smaller orbit around its star than it originally formed at. The Robo-Owl results support that idea. You can learn more about the project on the team's website. Reference Carl Ziegler. Robo-Owl COI survey LGSAO imaging of every Kepler planetary candidate host car, 231st AAS meeting. Abstract 128.05. Carl Ziegler al. Robo-Owl Kepler survey IV the effect of nearby stars on 3,857 planetary candidate systems. arXiv.org. Posted December 12, 2017. Learn more about exoplanets with MITU astronomer Sarah Seeger in our Exoplanet webinar.